Assalamualaikum and a very good day. Abi to all. Welcome to our exclusive webinar series today entitled P&A Permanent Barriers, What, Where and How Many. And these will be presented by our Principal Expert Trainer on Well Abandonment, Steve Jewell, sign in from Aberdeen at 7 a.m. in the morning. Thank you, Steve, for joining us today. And welcome everyone. It is an honor to welcome everybody to the session today. I hope everyone is safe, healthy, and well at the comfort of your place. My name is Faiz Latif. I'm from Smart Training, and today I will be the moderator of this webinar. Let's start with a bit of safety moment in the light of the surge of COVID-19 cases at the moment. Perhaps we can remind ourselves some of the practices that under our control that we can practice daily. The first one is try to avoid the three C's: crowded places, confined spaces, and also closed conversation. And we try to practice the three W's. Always try to wash your hands or using the sanitizer. Always wear a mask and try to always get updated from our Ministry of Health warnings of this COVID-19 outbreak. And I really hope that everyone is in a good shape and also your family is well as well today. Next, some best practices for online webinar. This is the webinar for you, and we expect some curiosity after this presentation. Feel free to ask question. It's just that we hope that you can drop your question in the chat box, and definitely we will discuss the question during the Q&A after the presentation by the speaker. Please take down notes for effective learning. And number 3, this is quite famous. If you cut off due to the poor signal, feel free to click back the provided link to join us again. And next is please take turn to speak if you are if you want to ask for the question during the Q&A, but during the presentation, or if you are not talking, we hope that you can mute your mic so that it is not interrupting the presentation flow. Next, lastly, is please join the session on time, and everybody here is just on time, and thank you so much for being on time, and you're not missing any important points just yet. Our plan for today, simple. We estimate 1 hour of the webinar. We have some opening currently, and then we'll go on with the presentation by speaker. It's estimate around 40 minutes. We will discuss, or Steve will discuss, on the permanent barriers in offshore well abandonment, and secondly on the verification. And as I mentioned just now, we will have a Q&A session. This one we will take the question from the chat box, and Steve will provide the feedbacks and answers on the questions. Next, we'll have a closing, and we expect to end our session today by 4 p.m. It's an honor for our organization, Smart Training, and I hope to introduce briefly about our organization. We are the Malaysia's integrated professional training provider to energy industry, and we are a Petronas licensed company and HRD Corp registered training provider. There are 6 categories that we are focusing on at the moment to provide the in-demand and world-class trainings. First is the oil and gas, zoom into the subsurface and also upstream sector. And one of it is basically the P&A that we are focusing on as well. Next is the energy transition. It's very famous that our clients are asking for the support on the training, the in-demand competency at the moment, whereby, for example, on the CCUS, carbon capture, storage, and utility and storage, hydrogen, and as well as the fundamental of the energy transition itself. We are supporting a few clients at the moment in Malaysia. Next is metering and allocation. We are offering structured and quality training. There we have around 7 courses. These we partnered with Tupsud NEL from the UK to support the demand in Malaysia and the region. Digital transformation on the big data, machine learning. We know that at the moment we are digitalization driving the cost down and increase the efficiency. Definitely we want to be the supporter of this, and we provide around 20 or 30 courses, and this is in partnership with Asia Academy. Health, safety, environment, and risk management, and also the business, which is the soft skill part, management, and also leadership. We offer 4 flexible training solutions. You can have it as in-house, public, e-learning, and also live online. Just like today, we have a live online. Steve is again at 7 o'clock in the morning in the Aberdeen now, and we are here around in Malaysia at 3 p.m. We have no issue to do that, definitely with our global network of expert trainers. And this is what we want to offer to our clients, to our market, whereby it is comprised of proven Malaysian international subject matter experts. And what important is having the local and global experience so that it can be distributed and also be helping transforming our clients and professionals. We do have experience in serving a range of clients from operators, service providers, regulators, and also institutions. And what I want to highlight as well, most of our courses are HRD Corp claimable, which you can claim up to 50% to 100% cost fee from HRD Corp. Okay, so that's basically from Smart Training. And if you have any question or you want to know more about us, please feel free to go to our website, www.smarttraining.com. Today, we welcome you to experience with us, right? Like other professionals, like other clients that we have. And it is an honor to welcome everyone to be together today to have one objective, basically to learn more, to upgrade ourselves with the knowledge, proven knowledge, and let the proven knowledge flows. All right, so on the topic today, if you have a wonder how many wells to be P&A, this is based on a Petronas Activity Outlook 2022 to 2024, and it seems increasing year by year, 2022, 2023, 2024. Have a look at the blue color. This is the wells to be P&A, right? And total up for the next 3 years, there will be 121 wells. It is an exciting journey, but also there's a huge responsibility for players, for operators, regulators, and also professionals to carry on this obligation by the operators to plug an abandonment, because there are fields who it's already at the end of the life cycle. With that, I would like to introduce you with our speaker today, Steve Jewell. He's our principal expert trainer on well abandonment. He's based in the UK, and he's a UK-based decommissioning advisor. I think this year he has 41 years of experience in oil and gas industry, expertise covering in well construction, in drilling, completion, workover, and abandonment, and also subsurface, geoscience, reservoir engineering, production engineering. What we want to learn or earn from the sharing is because he spent over 13 years of working on various decommissioning projects across the world, and this is focusing on plugging and abandonment of well, which is the single cost with the highest cost in this decommissioning project. And since 2019, and he has trained P&A professional in Malaysia from Petronas Cairgali, Repsol, Inquest, Halliburton, Archer, Super Energy, Vantage Energy, and Uzma. And on the side note, he's also UK Chartered Engineer, Fellow of the Institute for Material Mining and Minerals, member of European Engineer Institute of Directors, and of course, Society of Petroleum Engineers. With that, ladies and gentlemen, I wish you sit back, relax, and enjoy the session. And let us welcome Steve Jewell to take the screen. Please welcome Steve.
Okay, thanks, Faiz. Thank you. Let me just get my presentation up. Okay, I think we're good to go.
Good.
Great. Okay. Well, good morning. Well, good afternoon, everybody. I think most people are in the afternoon. I know there are people from all over the world here. So where I am, as Faiz has said, is in Aberdeen. The sun is just coming up, or at least it would be coming up if the sky wasn't so grey. It's raining here. If any of you have been to Aberdeen, you'll know that's quite normal. Okay. Title of today's talk is P&A Permanent Barriers. What are they? Where should they be placed? And how many should we put in the well? This is part of a 5-day online training session, which I do for Semarang. and I'm going to give you a little taster of part of that course today. So before I do that, just a little bit about the company I work for, Well Decom. We're independent advisors and consultants. We're decommissioning specialists, and of course we do technical training. And this is what this webinar is to introduce. We're a UK-based company based in Aberdeen here, and but we're active worldwide. Established in 2016 as a company. I've been working in decommissioning for a number of years before that, but the amount of well decommissioning in particular in the North Sea has been growing. The levels of activity are about 10 times those of Malaysia, maybe a little bit more. Okay, if you want to find out more about our company, the website is welldecom.com. Okay, so let's get on with it. Let's talk about well decommissioning, and the primary objective of well decommissioning, of course, is to permanently seal off all possible fluids, and that could be it's primarily hydrocarbons that we're thinking about, but it could be water, hydrocarbons or water, to prevent them escaping or cross flowing within the formations. And then clearing the seabed so that it looks so there's no residual equipment or any trace really of us being there and drilling wells. In essence, what we're doing is we're trying to restore the caprock. So the caprock is the seal, the geological seal that's kept the hydrocarbons in the reservoir over many millions of years. Okay, so we're trying to restore that. When we develop an oil or gas field, we obviously penetrate the caprock in order to release the hydrocarbons. When we decommission the wells, we need to restore that caprock so that the fluids cannot escape. We have the added complication of there being other formations, potential formations that we need to also isolate. But we need to isolate every source of fluids to stop them coming to the surface, and we may also need to stop them flowing between the various formations. And that's the objective of decommissioning wherever we're operating in the world. Okay, regulation and guidelines are very important because they influence, how many plugs we need, where we're going to set them, what length they need to be, what sort of materials we're allowed to use. So regulations and guidelines vary from place to place. Every place you go in the world, you'll find that it's slightly different. What I've shown here just on this slide is two examples. One is in Malaysia. I know quite a few of you are tuning in from Malaysia. So the Petronas procedures and guidelines for upstream activities is where you will find guidance and the requirements for well abandonment. They're slightly different, but fundamentally the same as we have in the UK, where the guidelines are generated by the industry, the ones on the right there. The latest edition there of the well decommissioning guidelines is June 2018, and these are constantly reviewed by the industry as best practice develops. Okay, so there's just two examples of regulations and guidelines, but they are important because they tell us how many plugs we need and where we put them and so on. They will influence that. So to give you a taste for this, just taking those two examples in Malaysia and the UK. In Malaysia, there are two broad options when it comes to well decommissioning. What I've described as the plus or minus 30 meter method, and then the second, what's called or described as the Caprock restoration method. And depending on the wells, the nature of the wells, either of these two approaches could be adopted. Now, I'm not going to go into the plus or minus 30 meter method. We just don't have time today, but I do cover this in the course, in the full course. The Caprock restoration method is the only method that's acceptable here in the UK, and you can argue about whether that's appropriate in certain circumstances, but that's the way we do it here. It's the way it's done in many parts of the world. In Malaysia, you have an alternative. Okay, so I'm going to focus on the caprock restoration approach because it's more broadly adopted worldwide. Okay, whatever way you approach this, wherever you're operating in the world, the objectives are broadly the same when it comes to well decommissioning. We want to prevent the migration of fluids, formation fluids, through the wellbore to the surface or the seabed. That's usually the thing we're thinking about most. But we also need to provide downhole isolation between hydrocarbon zones if ultimate recovery might be jeopardized due to cross flow. So we've got to think about different zones. If we have two reservoirs which are hydraulically isolated, then they may need to be isolated as part of the decommissioning process in order to prevent cross flow between the zones. We may also want to prevent a cross flow between a hydrocarbon zone and a water bearing zone. So we need to think about that as well in the design. So those two things are very important. We also need to think about protecting freshwater aquifers. Now, this is primarily an onshore consideration. So if we're drilling onshore, then freshwater aquifers near the surface need to be protected. This isn't an issue for offshore because the water, even close to the seabed, is going to be partly saline. Okay, so the Caprock method, just to talk about that a little bit. What does it mean? Well, essentially, it's about restoring the caprock. So the seal, the geological seal that exists to keep the hydrocarbons in the reservoir and has done for many millions of years, we need to restore that seal where we have penetrated it. In other words, where we've drilled a well through it. So it needs to provide a continuous permanent barrier across all annuli in a suitable sealing formation. Okay, so that usually means the caprock immediately above the reservoir, but there are options if we have other sealing formations. Okay, the caprock should be laterally continuous with the adequate strength and thickness to contain the maximum anticipated pressure from the zone being isolated. So we need to think about how thick the caprock is. We need to be reasonably assured that it's laterally continuous across the reservoir. So we can't choose a formation which is only appears in some of the wells in a particular reservoir. It needs to be present in all the wells. Otherwise, it's not. It may not be laterally continuous, and it needs to have that thickness there to sustain the maximum anticipated pressure. Now, usually what that means is when we think about a reservoir and its initial pressure, if we to drain that reservoir, the pressure may go down, and particularly in a gas reservoir, it may never recover. Usually the worst case we could anticipate is full recovery of virgin pressure. So if we've drilled into a reservoir, we've depleted it, the worst case in well decommissioning terms is that pressure eventually restores back to the pressure it was when we originally developed the field. And so when we think about the caprock that has to withstand a pressure as part of the decommissioning, we generally think about the original reservoir pressure. Okay, the permanent barriers need to isolate both inside the casing and the annulus between the casing and the caprock. And this is probably the most important aspect of well decommissioning that we give most thought to. But we tend to forget the annulus. Okay, we tend to focus on the cement, usually, that we put inside the casing. And where are we going to put that? How long does it need to be? And is it going to withstand the pressure? But whilst we need to think about that, we also need to think very hard about the cement in the annulus. which is going to lay alongside the plug that we plan to put in there. So this is often forgotten or brushed over because the Annulus cement was put in place when the well was originally drilled. It may have been done many years ago. It may have been done by a different company. It may have been done certainly by different people, and it's kind of, it's there, and we have to live with it. Is sometimes the approach we take. But we have to be sure that the quality of that Annulus cement is every bit as good as the cement that goes inside the casing. Okay, the base of any barrier that we put in place should be capable of withstanding the maximal potential pressure. Okay, so if we put a bridge plug in place there before we put the cement on, we'd like to ensure that it's good for the pressure as well, albeit it's the cement that provides the barrier. Okay, so it's just thinking about that maximum pressure we anticipate. If annular barriers, in other words, if the annular cement is defective, then remediation will be required. So although we may, we look at a cement bond log, convince ourselves that the annular cement is good enough, that's what we'd like to do. Ultimately, if we find that the annular cement is suspect, it's not good, then some form of remediation will be required. Now, in the Malaysian guidelines, this requirement for the Caprock method means it actually states there that you have to do what's called section milling, where you have to take out the casing and the annular cement before setting the plugs. There is a good alternative now, generally referred to as perf and wash, PWC, and this is where the casing remains in place and you wash out the cement. But I'm not actually sure if that is acceptable in Malaysia. It probably is by agreement. Okay, but maybe somebody could bring that up in the question and answers when we get there. Okay. What I've been talking about there is the permanent downhole plugs, which I'm going to go into in a little more detail. There is also, when you're thinking about abandonment, what I've described here is the surface plug. So this is a plug set close to the surface, usually set for environmental reasons. Here in the North Sea, a lot of wells were drilled in the past using oil-based mud, and that oil-based mud is still present in some of the outer annuli in wells here. So often a surface plug is set for environmental reasons, in other words, to stop that oil-based mud escaping over time. Okay, the surface plug isn't normally considered to be a permanent barrier. In other words, it can't withstand the reservoir pressure. If the reservoir pressure were to come below the surface plug, then we can't rely on it as a barrier. And the other thing to just take a note of, between the permanent barriers, which will be deep in the well, and surface plug, generally we fill the space with what I would describe as abandonment fluids. Whatever fluid is left in there should be of kill weight. In other words, it should have sufficient density to withstand the anticipated maximum pressure from the formation below. Okay, so permanent barriers. What are the permanent barriers? So these are the plugs whose job it is to keep those fluids back in the reservoir. They are often referred to as permanent barriers. So I'm going to go into a little bit of what does that mean? What does permanent mean? Some of the properties of permanent barriers and what sort of materials we would use in order to give us the right properties. How many barriers we're going to need? That's obviously a question we need to answer today. The positioning and size of the permanent barriers, what we think about in those terms, and open hole and cased hole requirements and how they may differ. Okay, that's what I'm going to talk about now. So the first question is, well, what does permanent mean? I've listed a few definitions here, and I don't really want to get into the subtleties of language, but you can see if you read these some intricate use of English to try and describe what permanent means. So lasting or intended to last or remain unchanged indefinitely. That means forever. Existing perpetually, that means forever. So we get into some semantics here about what permanent means. I think, practically speaking, from a pragmatic point of view, we must do our very best to design the plugs so that as far as we can reasonably foresee, they will last forever. Now, we don't know what's going to happen over millions of years, but I think we do know what could happen over 1,000 years or maybe even 10,000 years. And I think that's the basis on which we should be thinking about our permanent barriers. What sort of materials can we use or should we use for permanent barriers? Well, the properties that we need are a barrier with very low permeability, so low effectively we don't have flow through it. Even cement has a permeability, but it has to be very, very low. Just as a caprock has permeability, it's extremely low, and if it's sufficiently thick, we're never going to see any flow through it. It needs to provide an interface seal. So in other words, with the casing, if we're putting cement inside the casing, we need to get a seal between the cement and the casing. We don't want it to move. If it moves, then it may introduce flow paths. So it must be, once we put it in place, it needs to stay there. It needs to provide long-term integrity. Well, in fact, it needs to provide integrity forever, is what we're trying to design. So that's on a permanent basis, as far as we can reasonably do that. It needs to be resistant to all downhole fluids. So, in most reservoirs, we may be thinking about gas and oil, sweet oil. But as I'm sure you know, some reservoirs are sour. We may have H2S, we may have CO2. There may be other fluids which we produce, which could attack the materials that we're using. So we need to think about the fluids present and the materials that we're using so that we can reasonably expect that they're going to last a very, very long time. Okay, the permanent barrier needs to be mechanically suitable to withstand all foreseeable loads. Okay, so typically the sort of loads that we might anticipate would be the pressure, for instance, from the reservoir acting on the underside. So the permanent barrier needs to be mechanically suitable to withstand all foreseeable loads. The loads being the pressure from below and perhaps even movement of formations. When a reservoir is depleted, we may see changes to the geological or geomechanical properties of the formations above, and some of these formations may start to move. So we need to think about that. That's a load on the well that is foreseeable. What we can't predict is, tectonic movement as a result of the earth shifting, earthquakes, or at least certainly major earthquakes, and so on. So we need to think about foreseeable loads, and ultimately the permanent barriers need to be effective at all foreseeable pressures and temperatures. Okay, so we need to think about pressure and temperature in the subsurface and how that might affect the performance of our permanent barrier. So what material could we use? Well, 98, 99% of permanent abandonment plugs will be made from cement, usually class G. So this is a universally deployed material. It is very effective, and it's cheap. So cement is the material of choice. Now there are many other materials which can be used or could be used, and are being developed as part of new technology. So different types of resins, even alloys, bismuth alloys can be used as alternatives. But for the vast majority of abandonment, we will probably be using cement because it's readily available, and it's cheap, and it's highly effective. Okay, so that's that's what we expect of our permanent barrier, and the sort of materials we might use. Another key thing we have to think about when we're thinking about where we place our plugs is what's described in the UK guidelines of zones with flow potential. Okay, so these are the things that we need to think about when thinking about zones with flow potential. Now, the most obvious zone with flow potential is the reservoir. So the reservoir that we're trying to seal off, try to isolate. Clearly, it has flow potential. It has permeability. It has the ability to flow to surface. That's why we've developed that particular reservoir. But there may also be other zones higher in the geological section which also have the potential to flow. And we need to consider where they are, because we may need to isolate them from the reservoir, and we may need to isolate them from each other. So the things we need to think about is the potential of each of these zones to outflow to surface. So can they reach the surface? Potential flow between the zones in the subsurface. Consideration of flow, for instance, of hydrocarbons to usable water aquifers. So this is an onshore requirement. Don't need to think about that too hard for offshore. And then, of course, we need to think about the different formation fluids in these reservoirs or these zones, the various pressures and temperatures. Some may be overpressured. The rock strength, potential flow rates, the sustainability of flow. So some formations close to the surface may have a little bit of gas, but it's maybe shallow gas which will deplete. So how sustainable is the flow? The environmental impact of any escapes, and the feasibility of any remediation if the worst happens and we get to flow to surface. Okay, so these are some of the things we need to think about with zones with flow potential. Okay, so we talked a little bit about the barriers there. How many barriers do we need is a question we need to answer today. What I've done here is kind of extracted from the UK guidelines, and I think they're generally pretty robust and applied in other places. If anything, in other places it might be you may be a little more conservative in thinking about how many plugs, but basically all zones with flow potential identified need to be isolated from each other. They need to be isolated from the surface, and they need to be isolated with a minimum of one permanent barrier. Okay, so this is the kind of the minimum requirement. If we only have a reservoir where we've taken oil and gas, but no other formations with flow potential, then we should be able to isolate that reservoir with one barrier. That's the minimum requirement. However, we may want to think about two barriers if a zone requiring isolation is hydrocarbon bearing and or is overpressured and water bearing. So either of those. So just taking those 2 bullet points, what I would say is if we've drilled a well and we find that it's a dry hole, it's an exploration well, it's a dry hole, there are no hydrocarbons, then in theory we could just abandon that with one permanent barrier. If we find there are hydrocarbons, then we'd probably want to use 2 permanent barriers. But the assessment of how many we actually need in our particular case, good practice says that we really ought to do it by risk assessment. In other words, we shouldn't just rely on what it says in the guidelines. We should think about the risks of our particular scenario and how we're going to achieve the principles, which is to prevent the flow of fluids to the surface, to other formations on a permanent basis. Okay, and so what I would recommend, and what good practice really says, is that you really ought to do a risk assessment to determine how many barriers you will need in your particular well. Okay, so position of barriers. I'm going to show you some examples towards the end here to give you a flavour for how many barriers we need. The position of the barriers. Well, if we've got two barriers, the primary one should be set above the zone with flow potential and across a suitable caprock. So again, for the reservoir, that if we're abandoning a reservoir, this is reasonably straightforward. We know there's a caprock immediately above the reservoir, and so that's typically where we would want to put our primary plug. If we're setting a second plug, then it also should be set across a suitable caprock. Now that may be the same caprock that sealed the reservoir in place, but it doesn't have to be. It may be a second caprock or sealing formation higher in the stratigraphic column, higher in the section. So of course, if we're doing that, we need to make sure, as I said earlier, that that particular formation is laterally continuous across the reservoir. Otherwise, we might find that we've got a leak path. Okay, so they're the principles. In all cases, the barriers need to overlap good annular cement. So it's no good just putting a good cement plug inside the casing. The cement outside that particular place also needs to be good. And the formation fracture pressure, of course, at the base of the barrier needs to be greater than the maximum anticipated pressure. In other words, that plug needs to withstand the maximum anticipated pressure we would expect to see below that plug. In addition to that, a secondary barrier of one zone with flow potential could be the primary barrier for another shallower zone with flow potential. Okay, so that's sounding a little complicated. I'll illustrate this with an example shortly. But basically, a secondary barrier, thinking about one zone, can act as a primary barrier to a second zone. So I'll show you that shortly. Okay, so primary and secondary barriers. This is how they might look in one example. This particular example has two zones, flow potential, zone A and zone B. So you can see, looking down at the bottom first, zone B, we would put a primary barrier above that zone, and you can see that the cement across that plug, I'm not showing any lengths at the moment, the cement across that in the annulus needs to also be sealing and good. And then if we've got a second zone, zone A, above it, you can see the primary barrier to zone A sitting above, and then a secondary barrier to zone A sitting above that. Okay, the primary barrier to zone A is acting as a secondary barrier to zone B. So in other words, we've got two zones, and effectively we've got two barriers for each zone. But of course, we've managed to achieve that with only three barriers. Okay, so so this can be a little complicated if you've got multiple zones that you need to isolate from each other. It's generally not that difficult. We can usually identify the zones with flow potential reasonably easily and design our plugging scheme reasonably simply. Okay, so this is showing individual abandonment plugs, permanent plugs, but we haven't got into precisely where they're located or the actual length, and we'll talk about that shortly. Okay, so to give you an actual example, here's a a stratigraphic column, simplified, of course. We've got the main reservoir near the bottom there, permeable zone C, and then we've got two other permeable zones, sandstone B and sandstone A, higher in the section. And in between those, we've got different formations, but three different shales, which I've classed here as caprocks. So Caprock M near the bottom, the red one, Caprock L, and Caprock K. So a series, and this is very typical of what we'll see in a well. So if we're trying to abandon this particular reservoir, so the main reservoir at the bottom, we need to think about those two sandstones, A and B. And this shows a scheme of abandonment where each of these is isolated from each other, and the main reservoir is also isolated. So starting at the bottom, you can see the main reservoir. In this particular case, the tubing has been cut and two barriers against the reservoir have been set just above the what was the packer near the bottom there. And then going higher in the well, we've got two bridge plugs and then two cement plugs put on top. And this provides isolation between the main reservoir and sandstone B, that's provided by the main barriers. And then between sandstone B and sandstone A, we've got two barriers, and then ultimately sandstone A is sealed off from the surface using those two barriers against sandstone A. So in this particular case, we've used 6 barriers to isolate 3 zones of flow potential, which includes the main reservoir. All right, so these are thinking about these barriers as individual barriers, but of course there are ways in which we can combine barriers, and I'll mention that very shortly. Okay, so how long should the plugs be? Well, this is how long is a piece of string sort of question, and what I would say is that the cement column, it needs to be at least 30 meters or 100 feet in length. It needs to consist of good cement to constitute a permanent barrier, and this would be considered to be good industry practice. Where the casing forms part of the barrier, in other words, it's not open hole, then we need that to be good in the annulus, as I mentioned, adjacent to the internal plug. We can combine 2 plugs, and sometimes we refer to this as a combination barrier. Okay, things to think about. Not all cement is good, so you need to evaluate annular cement, for instance, with some form of cement bond log if you can. You may need to look back at the cementing records of a particular well. Okay, your own company's policies and standards may be important. They may be more rigorous than the guidelines available in your area. And as I've said already, risk assessment is good practice, no matter what standards or guidelines you're using. Okay, I'm going to go through very quickly because I've just noticed the time, and so very quickly, just some examples. Here's an open hole example where there's one zone to be isolated. So we can put in 2 100-foot barriers of good cement. Or alternatively, we could put in a slightly shorter barrier. This is looking at old UK guidelines, in fact, of maybe 800 feet, and that effectively acts as a double barrier. The same for 2 zones, Zone A and Zone B here. We've got some isolation between the zones, and then the same scheme inside the casing. Cased hole example, we've got here, again, looking the same as the example I just showed earlier. Tubing's cut, we set a combination barrier or two barriers above the tubing, and that's going to isolate Zone A and B. If Zone A and B are in the same pressure regime, maybe they've been depleted as part of one reservoir development, then we maybe don't need to isolate them from each other. And so those 2 barriers act as an isolation for the entire reservoir. Remember that the annular cement has to be good where we set the 2 permanent barriers inside the casing. Okay, just a little bit on verification. I'm going to speed through this. Verification, of course, is how we check that our plugs are good. We need to verify them to make sure that they're in the right place. We set them where we said they were, and that they can achieve the required sealing capability that we've set ahead of time. So we may test a predefined acceptance criteria. That's good practice. Okay, so we need to fully document our barrier installation. We may want to check the strength development of the cement slurry and get that confirmed. We can check the position by what we call tagging, or measuring the depth of the firm cement plug. And in open hole, we can verify with a weight test. In other words, we apply weight to the cement plug, typically 10 to 15,000 pounds, with a little bit of rotation in case the plug moves. If we use wireline or coiled tubing, then we're weight limited. We may not be able to verify that adequately. In cased hole, we can also verify with a pressure test or inflow test. So just some guidance here. Pressure test needs to be a minimum of 500 psi above the maximum pressure expected. We don't want to damage the primary cement. We shouldn't exceed the casing strength. Okay, it's sort of common sense there. An inflow test needs to be at the maximum anticipated pressure differential across the plug. So we need to work that out in advance. Okay, we also need to verify the annulus cement. So this can be done with a log, as I mentioned, or we may look at the history of how the cement was set, how the annulus cement was set, to give us confidence that the cement is good. Ultimately, we may want to pressure test. Okay, so that's what this says. Okay, sorry about we got a little bit quick there, but I was obviously getting right into it there, and so just had to hurry along to make sure we stayed on time. So that just opens things up. I'll hand back to Faiz and to give you an opportunity to ask any questions.
Thank you, Steve, for insightful presentation, and definitely it looks like the experience is like in the training itself, in the discussing a bit detail on that one. And thank you for sharing on this topic. And now we open and give a chance for the participants today to ask any question, or perhaps you want to share your experience of P&A projects that you faced before, and perhaps you can discuss with Steve today. And let's allocate around 10 minutes for this Q&A session. And feel free to drop the question in the chat box, or if you prefer to do to ask the question using the mic, just raise your hand, and then we definitely give you the chance to ask the question. All right, Steve, I think I would like to start with a question first. Yeah, I think this has been asked by a few participants before. And you mentioned that with the amount of the P&A activities in the UK, tenfold in Malaysia, definitely there are a lot of experience happening over there. And in terms of the P&A permanent barriers, right? What is the common challenge that face for these P&A permanent barriers activity?
Okay, that's a good question. What I would say is that setting a cement plug inside casing is not a big challenge. That's the easy bit. What I would say is the real challenge is trying to ensure that the annular cement adjacent to that plug is also of sufficient quality. And we go through hoops trying to establish that with cement evaluation. So whether that's an old cement bond log, maybe from 40 years ago, is that telling us the cement's good? Do we need to run another log? If the second log is a little bit ambiguous, should we go to remediation? I think that's the thing that we wrestle with most, the quality of the annular cement where we're setting permanent barriers.
All right. Thank you, Steve, for sharing some experience from the UK market. And I would like to open the floor for a participant to ask any question to Steve. All right, it's coming from Suvik Sen. The question, Steve, for you: what aspects of pore pressure and geomechanics need to be addressed for decom?
Okay, well, the pore pressure is usually the thing we're thinking about most is the pore pressure in the reservoir. Okay, now we need to think about pore pressure in any zone with flow potential, but normally we're most focused on the pore pressure in the reservoir and whether it's going to restore itself. So generally, if we don't know, if we're not sure, we would normally assume that the pressure will restore back to its virgin conditions. So the pressure that existed before we actually started taking oil and gas out of the ground. The second thing about geomechanical is something I just touched on. When we deplete a reservoir, the pressure will go down and it will have an impact on the mechanical properties of the rocks above. Now, that impact may be very minor and we don't need to think too hard about it, but it may be quite serious. So we might, for instance, in the worst case, we might fracture the caprock above our reservoir. In other words, we've drilled into a reservoir, we've depleted it, and the caprock is no longer the seal that we had at the start. Now that's a very extreme example, but we need to study the mechanical properties of our formations if we suspect that that might be a problem, and that may influence where we place the permanent barriers in a particular well.
Interesting aspect on the pore pressure and geomechanics. Thank you for the question and also feedback from Steve. And we have a few more questions, quite interesting one from Timur Orekov. The question would be about the oil-based mud used as a fluid. Can oil-based mud used as a fluid left above the permanent barriers?
Yes. Different operators take a different approach depending on their circumstances. So this is normally a problem in old wells where they were drilled. When I started in the industry, we drilled wells with oil-based mud, and often they were left in some of the outer annuli, and they were effectively left as the annular fluid. So some operators will attempt to displace those, so to actually remove them so that they can't contaminate the environment. Other operators will put a surface plug to make sure that the oil-based mud stays there. So different approaches from different operators. But this can be a problem normally in old wells, but there's different ways in which you can deal with it.
Thank you, Steve. On that, I would say justification on how OBM used as a fluid left above the permanent barrier. We have more question from Shafiq Majid. He interested about the resin application. As alternative to cement, what is the challenge for resin application toward abandonment?
Oh, the environment. Okay. Well, normally the challenge is actual verification. In other words, convincing a regulator that that resin, and usually a much smaller volume of resin, is going to be as effective as cement. That's normally the challenge. In terms of the environment itself, thinking about if you've got cement which might be attacked by the fluids in place, then you can readily test that in a laboratory at different pressures and temperatures to demonstrate that that it's going to be able to withstand the intended environment. But you would need to demonstrate that to the regulator, I think, before they would consider an alternative to cement. So it's not just a question of just choosing material which is acceptable to you. You may need to also convince the regulator that it's acceptable in your particular country.
Interesting. Thank you, Steve, for the enlightenment of the resin application as an alternative to cement. Again, I would like to ask if anyone wanna ask question through mic, you feel free to raise your hand, or perhaps you want to share your experience on the P&A activity in Malaysia or probably overseas. Perhaps people, everyone can benefit it from the discussion today. Please feel free to raise your hand and open your mic. Yeah.
Maybe one comment phase while we're just waiting there. So on this final slide there, I've tried to summarize the answer to these three critical questions. Now it's not really it's not easy to answer these very simply, but if you remember nothing else, what is a permanent barrier? It's at least 100 feet of good cement or equivalent if you're not using cement. Where should you put them? Usually it's at the caprock, adjacent to the caprock, and it needs to be across the whole well section, including the annulus. It's not enough to put a cement plug just inside the casing. It needs to be in the right place at the caprock, and it needs to go right across the well bore. How many do you need? Well, you really ought to use risk assessment, but generally you will end up with 2 permanent barriers for each zone with flow potential. So defining your zones of flow potential is very important right at the start, but you'll probably end up having 2 for each zone. You may combine them into a single barrier, depending on what your guidelines allow, but generally these 3 rules of thumb, as I described them, effectively provide the answers to the questions in this webinar.
All right. As promised, Steve provide the answer for the 3 questions on the what, where, and how many. All right, Steve, I think we have, let's give one last question to be discussed today. And this is a unique example. Consider an old well with highly depleted reservoir, which cause production-induced geomechanical instability, probably little subsidence, and buckle the casing. Yeah, so that's the scenario. And in your opinion, how to proceed in such cases?
Okay, so this is where maybe the casing has been buckled higher in the well bore, and how you overcome that. Well, that's it. The answer is it depends on the individual case. So examples I've come across with this in the Southern Basin in the UK here, we have a very thick salt section in the well, which can cause the collapse of casings, and that can cause various problems. It depends on where in the well and how much access you have. Ultimately, if the well continues to flow, then the very worst case is you might have to drill a relief well in order to get the isolation deep in the well. I don't know of any examples where that's happened here. Usually there's been sufficient access to get something into the well in order to set a plug in an appropriate place. So for instance, if you can get the tubing out and you can get some cord tubing in there, then you may be able to set a cement plug deep enough. This isn't an uncommon problem, particularly in very highly depleted reservoirs. And I suspect from the question, this has obviously happened to somebody, and perhaps you've not been able to solve the problem. I'm obviously not sure, but usually to try and answer as briefly as I can, every well is different. If you've got some access, usually you can find a solution, and if you can't, then you may ultimately have to drill a relief well.
Thank you, Steve. Yeah, I think that's the beauty of P&A. Unique wells have a unique solution, and yes. Yeah, that's basically a very good question to bring on the case. What really happened for the old wells? Yeah, and yeah, I think we have reached to the end of the Q&A. Thank you so much, Steve, for your insight, for your answers for the question, and thank you so much for those who ask the questions and make this discussion insightful for everyone. All right, I think there are a few things that before we go. Excellent, beautiful. And last but not least, definitely like Steve has shared in front just now, whereby we are offering the full training on the offshore well abandonment, plug and abandonment and decommissioning. And just for your information, since COVID-19, we are offering also the online mode, whereby we will conducting on the 5 half days. And also, I really hope that the border will open soon and we can have a face-to-face training. And we'll be back to classroom. It will be a 3 days training. And about the training mode, definitely if you have a good size of your team or your company, we can have it as an in-house at your preferred venue and date. And it also can be, the content can be customizable to suit best with your requirement and your needs. And for the public course, perhaps some of you might wonder, will be organizing in May and August in 2022. And this one, I'm not going to read it through again. I think Steve already have gone through it. And on the key modules, this is the key modules that we still will cover on the basic understanding of well P&A, long-term well integrity, planning for the well decommissioning tools and technique, best practices, and we have bonus, right? 2 times a decom challenge. And for your information, this course outline has been improved since 2019 by the feedback of the operators, of the service providers, and definitely we want to continue to support and to help you perform better for these P&A activities. And good news is that if you are a company, is Malaysian company and registered with HRD Corp, you can claim part or some of the cost fee through HRD Corp. And worry less about the fee and we just focus more on the competency. And for any questions and requests, email to us at smartsolution.com, or if you want to speak with me, this is my number 019-699-8609. And with that, ladies and gentlemen, thank you again for choosing us to spend your time 1 hour plus today. We apologize for a bit of extended time. And I hope to see you again in the future. Let's stay connected and follow us at our social media Smart Training. With that, stay safe, everyone, and goodbye for now. Assalamualaikum.